All right, welcome to what will hopefully be a very quick lesson on limits. Now, full disclosure, there's something called the epsilon delta definition of a limit that is truthfully the only way to prove that a limit exists. I am not going to do that. So as we do these limits, I am never going to actually prove that a limit exists. We're just going to talk about it kind of in a overview kind of sense and a common sense approach. If you take calculus at college, you will learn the delta epsilon definition of a limit. You're just not going to learn it here. So let's say I want to evaluate the limit of 5x squared y over x squared plus y squared as the point xy approaches 1, 2. Well, first thing you're going to do whenever you're trying to evaluate any limit is you're going to plug the numbers in. Not because that always gives you the value of the limit, but because it gives you a starting point. So if I plug 1 in for x and 2 in for y, I have 5 times 1 squared times 2 over 1 squared plus 2 squared, which is 10 over 5, which is 2. Now I need to figure out, is this the actual answer for the limit, or did something happen I'm unaware of? Well, I'm going to think about this multivariable function. That multivariable function does not exist at the point 0, 0, but everywhere else, it doesn't have any problems. Doesn't have any vertical asymptotes other than 0, 0, something weird happens. But otherwise, there is nothing wrong with that function except at 0, 0, which means at the point 1, 2, it should still be continuous, which means the limit should exist and equal the value that we got. So long story short, plug in the point that you're given into the expression. If you get an answer, check to make sure that that answer isn't anywhere near an asymptote or a hole, something like that. If it's not anywhere near any of those things, that is your answer. So if I want to show that this limit equals 0, but I want to plug in 0, 0, when I do that, I'm going to get 0 over 0. Uh-oh, that's an indeterminate form. So if I want to show that that limit actually equals 0, one of the things that we can do is we can approach it from different, approach it from different lines. Now, if you remember when we were in BC Calc, if I said I had something like this, and let's say this is 4, and let's say this is 5, and we'll call this 7. If I take the limit as x approaches 4, I'm going to get something that does not exist. However, if I take the limit as x approaches 4 from the right, I'm going to get 7 because I'm approaching from the right, and the other way I can approach it is the limit as x approaches 4 from the left, and then I'm going to get 5. And what we talked about last year is if these numbers don't match, which they don't, the limit does not exist. If they did match, then the limit would exist even if there were a hole there and not a dot. Well, in multivariable calc, it's a little bit different. And instead of approaching it from either side, we approach it from different directions. So let's say here's a surface, okay? And here's a point on the surface. I can approach that point from here. I can approach it from there. I can approach it from here. I can approach it from there. I do not like green eggs and ham. I do not like them, Sam, I am. You can approach it from different lines. So as I go to plug in 0, 0, I get 0 over 0. I don't know what to do. So what I'm going to do next is I'm going to take the limit as x approaches 0 along the line y equals x. So you choose a line that goes through the point in question, and then you do substitution. So if y equals x, then this would be the equation 5x squared times x, x squared plus x squared. Again, I'm approaching along the line y equals x, which means I can do a substitution of x in for y, which means this is really the limit as x approaches 0 of 5x cubed over 2x squared, which is the limit as x approaches 0 of 5 halves x, which as x approaches 0 is 0. Now, does that show that the limit equals 0? No, it does not. It shows that from one direction, the limit equals 0. Well, how many directions are there? There's an infinite number of directions, okay? Infinite number. Can I show that infinite number? No. But here's something that I am going to say for our course. If I tell you show that the limit equals a certain value, I want you to show me 3 paths that approach this point that all give you a limit of 0. If you can show me 3 paths and I've already told you that the limit exists and equals 0, we're going to call that proving that it equals 0. Mrs. Fibber, that's not a proof. I know it's not a proof. That's totally fine. For our course, that's what we're going to live with. So let's try another path. So let's say the limit as x approaches 0 along the line y equals 0. Y equals 0 is a line that goes through 0, 0, isn't it? Yeah. So I'm going to say let's let x equal 0, or approach 0, pardon me, when y actually equals 0. So if y actually equals 0, I have 0 up here, I have x squared plus 0 down here, I have a 0 on top and a non-zero on the bottom. This equals 0. But Mrs. Fibber, isn't there a 0 on the bottom? You're plugging in 0. I haven't done that yet, though. And here's the cool thing about this. If you approach along a line where y equals 0, x equals 0, y equals 1 if it needed to go through the point, I am on the line y actually equals 0, like on that real line. So this 0 right here is an actual 0. It's a true 0, y equals 0. These x's are approaching 0. They're not actually 0. So this is 0 before this ever has a chance to approach 0 in the x. So this limit equals 0. Now, we've done all these where I have a limit where x is going to something. Let's let x go to something over here. So let's go along the line x equals 0 instead of y equals 0. So if I'm along x equals 0, this would be the limit as y approaches 0 of 5 times 0 squared times y over x squared plus y squared, which would be 0 squared plus y squared. And again, I have a real 0 on the top and a y squared on the bottom. That goes to 0. Okay, now, this existed because I told you it existed. I said, you know what? Show that the limit equals 0. Fine, that's what we're going to do. When the limit doesn't exist, we're going to find paths that give me 2 different values. So this one, I'm going to approach 0, 0, and I'm going to say, well, if I'm going towards 0, 0, I have 0 minus 0 over 0 squared. That's a 0 over 0. I don't know what that's going to be yet. So now I'm going to say let's approach along the line y equals 0 and see what happens. So I'll have the limit as x approaches 0 of x squared minus 0 over x squared plus 0. That's all squared, which is the limit as x approaches 0 of x squared over x squared squared, which is the limit as x approaches 0 of 1, which is 1. Cool. All right, I got 1 for my limit. Well, now let's try another path. So let's go along the path x equals 0 this time. So I'd be taking the limit as y approaches 0 of, let's see, negative y squared over positive y squared, because again, if x equals 0, those disappear. And that squared, which is the limit as y approaches 0 of negative 1 squared, which is the limit as y approaches 0 of 1, which is 1. Aw, man, I approached it along 2 paths and I got the same thing, but as is indicated by the title here, this limit is not supposed to exist. And again, for our class, I am going to tell you that ahead of time. I'm going to say this limit exists, show me 3 paths to prove it. This limit doesn't exist, show me contradictory paths. Now, how many contradictory paths? All you got to do is find 1 pair. I haven't yet found a pair of contradictory paths, so I've got to do some more work here. So let's go along the line, let's go along y equals x, because y equals x passes through 0, 0. So the limit as x approaches 0 is going to be x squared minus x squared over x squared plus x squared, again substituting x in for y, which is the limit as x approaches 0 of 0 over 2x squared. There we go, that one's 0. So I have 1 path that approaches 0, I have 2 other paths that approach 1, therefore this limit does not exist. So now I'm going to do it for this next one here. Again, I'm approaching through 0, 0, so I'm going to start along y equals 0. Start with the easy things. Limit x, limit x approaches 0 y already equals 0, x over x squared, which is going to be the limit as x approaches 0 of 1 over x. This limit does not exist already because 1 over x as x goes to 0 is undefined. Technically, it might go toward an infinity, but in this case, it would go to positive infinity and negative infinity depending on what side of 0 I'm coming from. So right off the bat, doesn't exist. Ding, 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 done. Didn't even need to show contradictory paths. I just found one path that doesn't work. And then we have a couple more limits here, which honestly, I think that we can go through pretty quick. So here's what I'd like you to do. I'd like you to pause the video and see what you can do with these. I'd like you to show that all of these don't exist, and then we'll come back and go through it a little bit faster. And yeah, we'll see how that goes. So pause the video, pause, and then we'll come back. I think the joke that we need to end with here has got to be a really bad one today. It is going to be, what did the ocean say to the sand? Nothing. It just waved.